Hi again. I just wanted to show you how to use the mole map and that it can be used for any conversion. And you just have to remember that what each aspect is asking you. Okay, remember when you're asked for particles, which include the terms atoms, ions, formula units, or molecules. If you're converting from particles to moles or moles to particles, you would use Avogadro's number of particles. Okay, and that particle term can be changed to any of these that you see here. Okay, so it could be atoms, it could be molecules, it could be ions, etc. Okay, if you were asked to find grams from the number of moles or from the number of particles, you do have to use the molar mass. Okay, this is from the periodic table. So depending on if it's just an element, you just find the element on the periodic table. If it is a compound, you have to figure out what the molar mass is before using it as a conversion. So you do have to take more time with that particular conversion factor. The other one is the volume of a gas from moles. Okay, we use 22.4 liters, and that's true, 22.4 liters of a gas if the gas is at standard temperature and pressure. It will not work for a liquid or a solid or aqueous solution, just gases at standard temperature and pressure. Okay? Not that you necessarily have to remember what standard temperature and pressure values are at this point, but you do have to know that they're being held constant, therefore this equality is true. Okay, so once we have equalities, we can use them to convert. Okay? And when we are converting, we set up our basic T, okay, and we start with whatever we're given. We put what we have already on the bottom, which means the units only, the have units. And then whatever we want for units, they have to go up top. So if we have the units adjusted wherever they need to be, so our given and our have will cancel out, that will determine how to use the conversion factor. So if we started with particles, whatever particles, then we'd have to put particles on the bottom of our fraction and put moles on top. If we started with moles, then we would reverse that conversion factor. So moles would be in your given area, then you'd also want moles on the bottom of your conversion factor. Remember, this conversion factor is the equality. So the top has to equal the bottom. The given is what we're looking for. So that is out on its own. But anytime you have your T, the top and bottom have to be equal. If we're going from particles to mass or mass to volume or volume to particles, we have to go through moles to get to particles, or particles, moles, and then volume, or moles, volume, moles, and mass. So this is the only way that we can get from these outer parts to go through moles. So if that is true, we would use a conversion factor that has two steps in it. So your given, your want, and your have, and again your want and a have. Okay, but so your ultimate have is your first step. Your last step. Your first step would be to get it to moles. So once you get to moles, you know you can go in any direction. Okay, so let's look at an example that we did not cover today. Okay, so here we have how many grams of gold are there in 4.21 times 10 to the 23rd atoms. So this is our given amount. Okay, identify that. We want to know grams. So that's my unknown. How many grams are in this many atoms? I need to be able to measure this. So what I first have to do is get rid of my atoms. So that would be where you put the number of particles. In this case, it's atoms of gold. Right? And I know I have to go to moles first before I can move on to grams. So since mole was not mentioned in this question, I have to go to moles. According to the mole map, everything goes to moles first. Then once I have moles, I can get rid of moles, and I can end up with my grams, which is the question that I want. So the grams of gold from the periodic table, and since it's only an element, it's really easy to find the molar mass. Okay, so this is your molar mass, and this is Avogadro's number. But notice both the top and the bottom, they're equal. Okay, and you can use the fraction however you need it. Okay, so if you were given moles, then moles would have to go on the bottom, so it wouldn't work out the way that we've written it. So keep in mind that it can be used any way that we need it to.